Welcome back. In this current session, we are going to discuss about the live demo on naive Bayes algorithm. So we have already discussed the theory part of this in a different session. So here we'll see how we are going to do the implementation of naive Bayes algorithm with Scikit-learn library. Okay, so as I have already mentioned that there are different types of naive Bayes algorithm based on the type of input we are supplying. So we'll be discussing on multinomial NB and Gaussian NB. So the first one we are going to discuss is multinomial NB. It has few parameters. Most of them are sufficient with default values. So alpha is something which is additive smoothing parameter. It's kind of doing the normalization, and fit prior is whether to learn class prior probabilities, because you remember that in the theory we discussed about prior probabilities for the class. So whether to learn it or not, so that this algorithm is taking it as input, and class prior is that if we have to learn it, then whether it will be adjusted according to the data or not, that is done from class prior. So the default values are sufficient, we can go ahead with that. And then we'll need this predict, we'll come back to that. So we'll start in the Jupyter notebook first. Okay, so here I am importing this module multinomial NB. Next I am calling this, and this is CLF. For the CLF I am fitting this with the vectors. So vectors is something that we got after text feature extraction. We got vectors, and we are doing this, and then we are supplying these vectors and the target value. So this is how we are actually giving training to the model, that how it should learn from the dataset, and the outcome, that how it should decide that for the next set of test data when will be supplied. So let us first execute this. Okay, so this multinomial NB is already executed, is ready with the training data. Now we'll try to predict the outcome for the test set of data, so that is vectors test. So I will call this predict method. Okay, so here I have written some description of this. So predict, it actually takes self, means for the training data I have already called that, so I am just calling clf.predict, and x is the classification of an array of test vector x. So here I am sending the test set of data, and it will return the predicted target values for x based on training data. So okay, so if I go back here, so here I have sent, first of all, when I have fitted it, I have called the training data set and the target value of all the training data, and based on that this model was trained. And then I am calling this predict method for this test data set. So based on the training, it will try to predict the outcome for this test data set. So let us execute this. So it is a predicted data set, it is generated for the set of test data. Now I will try to find out that how this predicted outcome is close to my actual outcome. So for that I am calling again this module f1 score. So in f1 score I am sending this news group test.target. So that is the already present outcome for the test set of data, and this spread is the new set of predictions of the data generated, that is the predicted output. And this average parameter, it can take different type of arguments, that how it will do the average of the output. So we'll come to that later, but the purpose is that I want to know that how close the predicted outcome is matching with the actual outcome. So let us execute this. So I can see that the outcome is, it is 0.74. So it is something that you understand that it is how close it is to the actual outcome from the predicted outcome. Okay, so if I go back here, so this is the F1 score. Okay, so this is how we call F1 score. Now what is F1 score? So F1 is, this calculation is given, so F1 is equal to 2 into precision into recall by precision plus recall. Now this is again some two terms which we are not yet familiar with, so we'll discuss on that as well, that how this is calculated. Okay, next is in the multi-class and multi-level case. Multi-class, you understand that there can be possible different classes are possible as outcome. So in case of multi-class, and there are multi-level case, so multi-level case of course, so this is the average of the F1 score of each class with weighting depending on the average parameter. So is actually calculating the average value of multiple when we have set of data and we have different classes outcomes are possible, so it is just taking some average value. Okay, so it is like it is the comparison between the predicted output and the actual output. So now we'll see that how this F1 is getting calculated. So to understand that, we need to understand precision and recall. Okay, so we'll try to go in some detail of that. Okay, so here I have written something else, it is confusion matrix. So actually, to understand these two values, this precision and recall, then it is important that first we have to understand what is a confusion matrix. So don't get confused, it is very simple. So here you can see one chart, it is very clearly mentioned. So here you can see actual, it is predicted. So suppose for our whatever may be the test case, so maybe there are two possible outcomes possible. Okay, one is positive, one is negative. Okay, suppose it is a kind of binary output, so it can be positive, it can be negative. So these are the two possible outcomes, positive and negative. Okay, so suppose for a particular case, this actual data can be positive or negative, and for the predicted output also it can be positive or negative. Now I am taking one case where the actual output is positive and the predicted output is also positive. In that case, this type of outcome is called true positive. That means that I got positive as predicted output, and in reality also it is a positive data. So it's just like matching in the positive way. Next one is, suppose actual output is negative and in the as a predicted output I got positive. So it is false, means it's wrong. And how it is wrong? Because I have wrongly predicted is as positive where it was actually negative. So this type of output is called false positive. So here positive has come as predicted output, but that is wrong. Next one, here now I am coming to this cell. So here the case is that actual output was positive, but I got it as negative, means as my predicted output. So in that case it is called false negative. That means the actual case was negative, but actual case was positive, sorry, but I have predicted is as negative. So that is called false negative. Now the fourth cell, here actual output is negative and I have predicted also negative. So it is true, means what is the actual value? It is matching with the predicted value, that's why it is true. And what is the value? It's negative, so that's why it is called true negative. So you can see these two cells are green, they are written as true. So for these two cases, this cell and this cell, for these two cases we got the correct outcome, means it is matching with the actual and predicted. And here both the things are positive, here both the things are negative. And these two cells which are in red, I can see that it is written as false. Why false? Because here the actual and predicted outcomes are not matching. So why false positive? Because actually it is negative but predicted as positive, that's why it is false positive. And here it is false negative, where? Because Actual outcome is positive but predicted outcome is negative. That's why it is false and negative. Okay, so this matrix we call it as confusion matrix. So you understand that when I am comparing the actual outcome with the predicted outcome, we can have these four possibilities. Okay, so I guess it is clear. Next we will move to precision and recall. So what is recall and what is precision? So here the definitions are given. So recall equal to true positives divided by true positives plus false negatives. Okay, so if I go back here, so true positive and false negative. So these two, true positive and false negative, you come back here, true positives plus false negatives, and at the top we have true positives. So means this. So what is this? If I take these two part, that means it is the entire set of all positive actual outcomes. So this set is the total number of positive outcomes actual, and this is the correctly predicted positive outcomes. So now I can define recall as the total number of positive outcomes that is correctly predicted divided by the actual number of positive outcomes. So it is, you can say it is the fraction of correctly predicted positive outcomes from the entire set of positive outcomes. So if you are not clear, we can go back here. So it is true positive plus false negative, that means these two cells, that means it is all the actual positive cases, and this is what it is, the actual positive cases which are predicted also as positive. So that is called the recall. So here we are getting the fraction of correctly predicted positive outcomes among the entire set of positive outcomes. So that is recall. And precision is true positives divided by true positives plus false positives. So true positive and false positive, so it is like the entire actual data set, right? So some are positive, some are negative, so it is the actual outcome, and true positive is the positive outcomes, right? So I can say precision is that the fraction of actual positive outcomes correctly predicted in the entire set of actual outcomes. So that is precision. So that is how we can define confusion matrix, recall and precision. And now if I go back here, so here we are calculating this F1 score as with this formula. So you can understand this is somewhat is giving us that the fraction of the entire outcome which is predicted correctly within the entire set of actual outcome. So this is how we calculate the score. So we are done with this naive Bayes for this multinomial NB, and next let us move to Gaussian MB. Okay, so it is another kind of naive Bayes implementation, and here it is Gaussian naive Bayes algorithm for classification, and the likelihood of the pictures is assumed to be Gaussian. So actually it is for the continuous data set. Okay, in the earlier example it was the kind of discrete data set, right? Here the values were some discrete values, but in Gaussian NB we are mainly doing with this Gaussian type of implementation. So let us go back to Jupyter Notebook. Okay, so here I am importing Gaussian MB and this trend test split. So we are going to implement this Gaussian MB algorithm on our iris plan dataset. So we are loading this Irish data set. Here I have put return xy equal to true, so I will get data here and target value here, and then I am splitting it in 4 parts: x train, x test, y train, y test. Let us execute. Now I am calling Gaussian NB, and I am just calculating this y prediction for I am supplying x train and y train. Okay, and I am generating the y prediction value. Okay, so here I have trained the model with this Gaussian MB algorithm, and now here I am putting this x test data set to it. I am feeding this to this model now, and I want to predict the outcome for this x test data set. Okay, so these are the list of predictions generated, and now there is a score method. Here I am supplying these two sets. One is the x test and y test. Y test is the actual outcomes, and I'm just trying to compare that how the predicted outcomes are close to this actual outcomes. So if you see, you can see that 0.94666, that means approximately 95% correct result I got from this Gaussian NB for predicting the outcome for my test data set. So if I go back to the presentation again, so this is the predict method. So I have sent this x, means perform classification on an array of test vectors. So once I have given training to the algorithm with my training data set, I'm not now supplying these test vectors in this method, and with this method it has predicted the outcome for this x vector. The y vector is generated, and then I'm calculating the score for I'm supplying the x means here x test, and y means the y test, and it is returning the mean accuracy on the given test data and level. So it's like the average of correct outcome. So it's just comparing every outcome of the test data with the predicted outcome, and it is generating some average score, that how close the predicted outcomes are to the actual outcome. So this is how we have executed these two types of naive Bayes algorithms with the help of Scikit-learn methods. Okay, so I guess it was clear to you. So thank you for now.